What's good, y'all? We're back with another video. So, let's get to it. Day 205. Let's see. YouTube.com/@boat. Day something. Okay, I also fixed the issue. I forgot to just check if it's negative as well. So, whoopsies. Yep. We're on 205. Perfect. Guessed correctly. So, let's do this one. This is the next one on the list. I think I already saw this one before. Or it's just the legal premium and I can't solve it, so yeah. Let's do Pacific Atlantic water flow. Probably not going to be able to do this, but whatever. There's an N by N rectangular island that borders both Pacific and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. The island is partitioned into grid of square cells. You're given an n by n integer matrix heights where it's the height above sea level at this of the cell at coordinates RC. The island receives a lot of rain. This is weird. The height above sea level of the cell at which coordinate RC. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, east, south, so up, down, left, right. If the neighboring cell is less than or equal to the current cell, water can flow from any cell adjacent to an ocean into that. Return a 2D list of grid coordinates results, where results of RC denotes the range where water could flow from RC to both Pacific and Atlantic Ocean. Oh god. Oh, this sounds like a DFS, not gonna lie. Yeah, these is consecutively, is it, what? Less than or equal to. Ooh. Let's try to see this. So we have this, right? 0, 1, 2, 3, 4, 0, 4. Okay, so the following cells can flow to Pacific and an Atlantic Ocean. So 0, 4. Pacific Ocean and what? Okay. So 0, 4 and 0, 4 Atlantic Ocean. How does that even make sense? Oh, I see. They both share it. Oh, okay. Right. 1, 3. So we have 1, 0, 1, 2, 3, 0, 1, 2, 3. Right. And then 0. What? Okay. And then 1, 3 goes to 1, 4. This is so weird. Alright, I gotta read this again. Heights, okay. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly either way, right? Anyway, if the neighboring cell is less than or equal to the current cell, right? Cell size, then water can flow from any cell adjacent to any ocean into. Water can flow from any cell. Water can flow from any cell adjacent to an ocean into the ocean. What? From any cell adjacent to an ocean into the ocean. What? That makes no sense. So we have 1, 3, right? That goes from. Oh, this is 1, 3. Oh, okay. Goes here. Goes here. I assume it's not gonna go up there. Okay, let's see this. We can't do this one because none of them are tall enough, right? We can do this because why not this one actually? Oh, because it has to be both the Atlantic and no, that doesn't make. Why not 3? Right. One, 3. Okay, this one is just flow. So we have to make sure that it flows to. Okay, so like okay, try to get to put. So I'm already on Pacific. I need to get to Atlantic, but I can't because there's none neighboring that's smaller, right? Let's try it again here, right? Let's try. I could go here, right? But wait, I can't do this because I mean, definitely not here. Definitely not that way. Definitely. Maybe I could go here, and here, here, and then I can't go anywhere. So it's just like it's not a good area. I can't get to Atlantic, so I have to get to Atlantic. So but here I can go. I could try up. Try here, and boom, we hit Atlantic. But we didn't even hit Pacific though. What? That doesn't make sense. Why is this here? So 1, 3 goes from 1, 3 to 0, 3, or I guess. Oh, what? Wait, what? This is 1, 3 goes to 0, 3. That's Pacific, but we didn't even mark that. Then 1, 3 to 1, 4 could get to Atlantic. Okay. Denotes the rainwater can flow from cell RC to both oceans. Okay, yeah. If I go here, I can hit Atlantic, and yeah, okay, makes sense. Here I am on Atlantic, and I can go from here. So like this one, 1, 0, 1, 2, 3, 1, 4 is valid because we can go from 1, 4 to 1, 3 to 0, 3, and then we are already on Atlantic, so just yeah. Do we have to sort this or anything? Then 2 is there. I feel like this is like a DFS type of thing, right? Just kind of keep going and just add to the list, right? Right, 2 right? 2 0 1 2. This is valid because I can go all the way to Pacific here. I can go to Atlantic here. Um, 3 0 can go to 0 1 2 3. I can go obviously on Pacific. I can go up. Oh no, I could go down, 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 down. Yeah, and oh no, I can't. Down, up. Or let's see, how did 4 or 0 1 2 3 4 0. Oh yeah, you're already touching it, so you don't need to go anywhere else. Okay, I can see a possible solution. We do DFS at every single one, right? So can you get to Pacific? Then can you get to Atlantic? And we know how to check for that by checking its range, right? I guess recursively calling its range. So I have this, right? Let's make some variables. How do we detect if we're on Pacific or not? I guess we can say length. Okay, so Pacific bound. So we can do minimum of heights, right? And the right. Minimum of heights 0. So that's Pacific bound, and then Atlantic bound, ATL, and bound. We just do the opposite. Max, you know. Oh, no. I don't want the actual value. The index. No, yeah, this will get me the... Oh, no. Oh, crap. Well, actually, Pacific bound is always going to be 0. And... yeah, 0, 0, I guess. Or not 0, 0, it's just like... 0... I guess row 0, right? Or if you're on column 0. So yeah, 0, 0. Not 0, 0 specifically, but... okay, I think this is fine. And then for this one, we can do... length of heights, and then length of... actually, okay. Pacific bound p bound row, which is gonna be 0, and p bound column gonna be 0. So I guess we can do this. Then we're gonna do right, and then we'll have another one, a bound row and a bound column, and this one is gonna be length of heights, length of heights 0. Okay, nah, I don't wanna. So like we have here, I want any of these though. So basically 0, 1, 2, 3, 4th. So yeah, length of, that's gonna be 5, so alright, so we got here the length of this. So this is gonna be the coordinates we want essentially, right? Basically, if the row is, or row or column is in that thing, then we're good. But we have to do this recursively. So we have this def DFS. We'll take a row and column, right? So basically, base case is if R equals PB row or AB row or equals AB. I guess we do this. Now I have to do this. R equals Pacific bound row, or R equals Atlantic bound row, or C equals AB. Let's do PB col, or C equals PB AB col. Yeah. Return true. Right? If any of those are true, then we're Gucci, right? Okay, so that's our base case. Let me clean this up a bit. Oh god, hold on, never mind. We'll do that later. So if these are true, right, then return true. Now let's say they're not, then we need to eventually, well actually this is not really a base case, right? I guess the base case is if we're out of bounds and we just want to stop, you know? So if R, I guess R is less than length of, let's write some more constants. Let's do row equals length of heights. Col is length of heights 0. So if row or col or min of RC is negative, then return false. We want to get out of there, so that's your nice recursive relationship there. Now if these are any of these trues, then that's nice, but other than that, if none of these are true, then we want to recursively go. So we're gonna do, let's do 3 P's here, and we call in r plus 1. But what did it say? Let's say up north, so I guess minus 1. And that's his name. And then so it's north south, so go down. And then we'll do again. Get this out of here. And then we need to go east west. So let's do minus 1 and then plus 1. Wait. Hold on. So east is right, and so it's this east west. Okay, so we got this right, and then basically, if any of these are true, I guess return, or I guess at north, south, east, north, south, east, west, right? Return north or south or east or west, right? If any of those are true, if none of them, then that's not a valid one, so that's bad. So all right, then we need to do a for loop for every single value. So for every I in range of length of heights, or I guess we could use row. We do, or actually we do RC. Call DFS on so we'll have a res here. Or DFS, right? On is let's do valid DFS RC. If valid, then res dot append RC. Return res. What do you think of that? Oh crap. I think I should do minus 1 here, because exactly heights isn't what we want. And I actually think this is wrong as well. We should do this. All right, let's see. Okay, max. Are we missing a case? If row equals row, or C equals, or isn't that true? Like, shouldn't we like eventually like hit a point where I guess we should also have a set, I guess. Yeah. RC in S S dot add RC. Yeah. Oh. S. The type bool is not iterable. What are you talking about? S is not a set? Iterable, what? If R equals row or C equals column or min is less than a 0 or R is S. Oh, what? Hold on, did I get this wrong? Actually, no, it's the same thing. Okay, I actually messed this up. I think I messed this up. I think it's length of height, and then for every C in a range of R. Yeah. Wait, what? Am I tweaking out right now? Range of length of heights 0. Right? Zero. Yes. Yeah, this is right. I don't know why. Set valid. I don't know why it's not working. Argument of type bool is not iterable. What? What does that mean? If R equals to row or C equals to that, or the minimum of R or C, right, is less than that, or the RC is in the set, right? S dot add argument of type bool is not iterable. What does that mean? What is S? Let's call this scene, bro. My God, bruh. That's why I was being weird. Wrong answer. Oh wait, hold on. I forgot a very crucial step. The crucial step is if we've already seen it, and also hold on. Let's say we go there, right? Make sure it's okay. Make sure it's not out of bounds. Make sure we haven't seen it already. Actually, not even seen. Make sure that when we visit this area, oh my god, I wish I had the previous, bro. I need to have the previous. Or actually, I can just check. No. Let's do this. Let's only call it, right? Right. If let's do this. If DFS minus 1, right? Or if R minus 1, I guess heights R minus 1. Dude, I have to do it at the recursive call because I want to do some error checking, right? Let's say those are valid. Let's check if heights of RC let's add a previous prev height, right? If prev height is greater than prev height, right? Then okay, so prev height. So now after each thing, the prev height, we can just put we would say RC. Then we have to add prev height. I guess we can just start with something that you can't really. It can't be smaller than itself, so that's a safe bet, right? Something that's not gonna trigger that, you know. So. So the prev height, let's assume it's smaller, so come on, this is my last attempt. I don't know if it's gonna work. Yeah, it just doesn't work. I'm adding way too many. I don't know why. Alright, let's see a solution. BFS, simple BFS. Wow, that's so clean. Yeah, I thought I had it, but I think this one is a little. Wait, what is actually wrong with mine? I think I'm just adding too much. Alright, yeah, I think I need to redo mine. Because I think mine is just. It doesn't go for. This condition doesn't check if it's both. So, let's redo it, guys. It's supposed to do both, and like both Pacific and Atlantic. So, what we should do is basically go through all the columns and do there, and then visit the output of both Atlantic and in Pacific, right? So like, okay, so DFS will have, right? So we'll have if min RC or rows equal to row, or R equal to row, or row, or C equal to call, return out, right? So if R C in scene, return if I think I get it now. So if if RC, or if heights RC less than prev, I think it should be greater than prev heights, because we want to always maintain it being smaller. Then let's see how they did it. Did they do that call? Yeah, 4 directions. So it's called all the 4 directions of DFS at R minus 1, C, heights R, C, and scene, 3P. Actually, we'll increment this. We'll do +1, -1, and do that. So that's perfect. Then we'll do for every I or R in range of rows. Basically, okay, that's my confusing part, is to do Pacific and Island column time and bottom time. Okay, so let's actually do calls, I guess. Call. So DFS at, I guess, that's why we have to make the P sets. Set. Okay. So we want to do the top row, bottom row, and then first column, bottom row. Okay. P, or I guess ours is 0 to C. I forgot mine. Heights. Height is, I guess, heights 0 C, and P. We'll have A. Oh, and then we'll do rows -1, C rows -1, right? For every R in range of rows, I guess we take these two, and then we'll have something different. So we'll have R to 0, and we'll have R to call -1. Oh no. Call -1. We have 0 R. We have R call -1. Then our return. So I return the list of every chord for chord in P and A. Okay. Okay. Whoops. All right. Okay. That sucks. What's happening here? Maximum depth. That's kind of sucky. Recursion error. So I'm not catching something. Oh, I didn't add it to set. Oh my god. Also, it should always be smaller. Like what I'm visiting should always be smaller. And then P, I guess scene dot add RC. Oh my god, bruh. Alright. This passes. Thanks for watching, guys. Kind of took the L on this one. I had the idea, but I didn't really find the way to combine the two. But anyway, thanks for watching. I'll see you tomorrow. Peace.